Hello and welcome to Future Tech. Today we are going to explore some amazing facts and figures about black holes, the most mysterious and powerful objects in the universe. Now let's dive into the world of black holes. What is a black hole? A black hole is a place in space where gravity is so strong that nothing, not even light, can escape. It is made of matter that has been squeezed into a tiny space, which can happen when a massive star runs out of fuel and collapses in on itself, creating a supernova. Some of the matter from the star escapes into space, but some of it falls back into the core and forms a black hole. How big are black holes? Black holes can be big or small. The smallest black holes are as small as one atom, but have the mass of a large mountain. The most common type of black hole is stellar, which has a mass of up to 20 times that of our Sun. The largest black holes are supermassive, which have masses of more than 1 million suns and are found at the centers of most galaxies, including our own Milky Way. The supermassive black hole at the heart of our galaxy is called Sagittarius A, which has a mass of about 4 million suns. How do we find black holes? Black holes are invisible because they do not emit or reflect any light. However, we can detect them by observing how they affect their surroundings. For example, if a black hole is close to another star, it can pull matter from the star and form a disk of hot gas around it. This disk emits X-rays and other high-energy radiation that we can see with special telescopes in space. Another way to find black holes is to measure how they warp the space and time around them. This causes light from distant stars to bend or distort when it passes near a black hole. This effect is called gravitational lensing, and it can create multiple or distorted images of the same star. What happens inside a black hole? The event horizon is the point of no return for anything that falls into a black hole. Gravity inside a black hole is so strong that it stretches and squeezes anything that falls in, creating a process called spaghettification. This means that an object would be torn apart into thin strands as it approaches the center of the black hole, called the singularity. The laws of physics break down at the singularity, and we do not know what happens there. Are there different types of black holes? Yes, there are different types of black holes depending on their size, shape and spin. For example, some black holes spin very fast while others spin slowly or not at all. The faster a black hole spins, the more distorted its shape becomes and the smaller its event horizon gets. Some black holes also have electric charges, which affect how they interact with other objects and fields. Another type of black hole is called a wormhole, which is a hypothetical shortcut through space and time that could connect two distant points in the universe. However, there is no evidence that wormholes exist or that they can be used for travel. What would happen if you fell into a black hole? If you fell into a black hole, you would experience some strange effects before you reach the event horizon. For example, you would see the light from outside the black hole get distorted and stretched into a bright ring around you. You would also see time slow down for everything outside the black hole while your own time would speed up. This means that you would see the entire future history of the universe unfold in front of your eyes in a matter of seconds. As you cross the event horizon, you would lose contact with the outside world and enter a realm of unknown physics. Depending on the type and size of the black hole, you might survive for a while or be instantly destroyed. If you survived, you would see the inside of the black hole as a dark tunnel with a bright light at the end. This light is the singularity, where all the matter and energy of the black hole are compressed to a point of infinite density and zero volume. As you get closer to the singularity, the gravity would become so strong that it would rip you apart into your most basic particles. You would also experience extreme tidal forces that would stretch and squeeze you in different directions. Eventually, you would reach the singularity and cease to exist as a separate entity. You would become part of the black hole and add to its mass and energy. Is there any way to escape a black hole? The short answer is no. Once you cross the event horizon, there is no way to get out of a black hole. However, some scientists have proposed some theoretical scenarios that could allow for some form of escape or survival. For example, quantum effects could create a way out of a black hole through a process called quantum tunneling. Another possibility is that some black holes could have hidden exits called white holes, which emit matter and energy instead of absorbing them. Some theories suggest that black holes and white holes could be connected by wormholes, creating a one-way passage from one point in space and time to another. However, there is no evidence that these wormholes exist or that they could be used for travel. What are some of the mysteries and challenges of studying black holes? Black holes are mysterious objects that challenge our understanding of physics and reality and open up new possibilities for exploration and discovery. However, they also pose difficulties and limitations for scientists who want to study them. Some of the challenges include: observing black holes directly is impossible because they do not emit or reflect any light. We can only infer their presence and properties by looking at their effects on their surroundings. Measuring black holes accurately is difficult because they distort the space and time around them. We need to use complex mathematical models and simulations to estimate their mass, spin, charge, and other characteristics. Testing black hole theories experimentally is impractical because we cannot create or manipulate black holes in a laboratory setting. We have to rely on natural phenomena and observations to test our predictions and hypotheses. Understanding black hole physics theoretically is incomplete because we do not have a unified theory that can explain both gravity and quantum mechanics. We need to find a way to reconcile these two fundamental forces of nature to fully understand what happens inside and around black holes. That's all for today's video about black holes. And don't forget to subscribe, like, and share this video with your friends. Thank you for watching, and see you next time.